In this part, we are going to talk about the math modules. And if you round using the round function to round the 4.5, you will get a 4. This is not what we usually think that this is round up if this is greater than or equal to 0.5. This is because the Python round function is round to the nearest even number. So instead of round to 5, it go to 4. So you can expect that if you round 5.5, this will round to the nearest even number, and this is also what we think before is rounding up to 6. So now we are going to use the math modules. So we have to import the math modules. So if you have 4.2, then if you are using the math.for, you will go to the lower integer, which is 4. But if you are going to use the seeding, math.seeding 4, it will go to 5. And there is some constant from the math modules, such as pi. You can see this is the pi that we go to use to calculate the circumference of a circle or the area of a circle. And the math.e is the exponential. So this just for those very familiar with the mathematics. And math.inf is the infinity, and the math.not a number .nan is nan. And now we can see actually the math.not base is exponential. So if you use a math.not and then you pass the exponential here, it will back to 1. So this is just like this one. If you using the log e and the base is e, and e is stand for the exponential, it will go to equal to 1. So this is the log rule. So I am not going to teach you mathematics. So I think this you should already know about this. And then if you're going to use the math.log and the base is 10, then you will get this is 4. And you can also do it by yourself, because not 10,000 and the base is 10, it will go to 4. Now you can see this is 10 times 4 is equal to 10,000. So this is applying this log rule. Now if you are going to use the a tangent, so a tangent is equal to the inverse tangent. So if you are doing the inverse tangent of 1, so if you look at this diagram, and I hope you already know that. So if you inverse tangent, it will back to pi over 4, and this is in radian, not degree. So pi over 4, and if you want to, this is actually equal to pi over 4, but you can change it to degrees mode by using math.degrees. So you can go to here and you can see this is 45 degrees. And you can check the table of sine, cosine, tangent at here. So this is actually math. So we can print it out. And this is actually equal to pi over 4. And you can check this by using print math.pi over 4. Now you can see these two exactly the same numbers. And you can change this to degree by using the degree modes or radian modes. So if you are already in radian, you can turn it to degrees. And pi actually is equal to 180 degrees. And if you have 180 degrees, you can turn it back to radians. So pi, you already know that this is 3.15, well, 3.1415. And this is the pi. And then we can use the random modules, and I think you already have a look at this before, because we already have used the random modules. So now we have to import the random modules, and if you're using the rand int, and you can see the description, you can return the random integer in range from A to B, and which including both these two integer. So for example, you may have a chance to output the 10, and now you will get the 3. And if you have the seed here, so you can see at here, if you every time you execute this line, you will get different. You may get different numbers. But if you already set the seed is 99, or actually any numbers, and then you go to rand in again. So no matter how many times I go to execute this line, you will still get the same numbers. So for example, if you output 10 times, for the rand seed is equal to 99, and then you print the random integer, you will see the 10 times you choose the number is the same. And now you go to here, and the first one is we go to create the list one, which is we go to create a random integer from 0 to 100, and then we go to choose create 15 random numbers, and the list 2 is just create a sequence from 0 to 20. Now you can see the difference. In this part, I just remind you how to use the list comprehensions. So for this one, you can see we have 15 numbers, and the range is from 0 to 100. We choose the number from 0 to 100. So it may have the same numbers, but for the list just range 20, it will just counting from 0 to 19. So the random dot choice is to choose a number from the list. So if you choose the random dot choice, you can see we have 17. But you can also choose not just one number. So for example, if this is k is equal to 15, so you can see it has the sample size is 1, but now we can choose 15. And then if we execute the result, you can see the result is here. We have choose 15 number. So for example, if you choose 5, you can see it only get 5. And you may not see it already has replaced the choice, and then what I mean is you may choose the same number again and again, but because you just choose 5 number, you may not see there are more than one same numbers. So for example, if you back to 15, now you can see we already have 317 here. And if you remember, we have used the collection modules before, and this is convenient to check how many numbers of each item. So for example, you can see 87 had two items is also 87. So if you do not want to choose the numbers with replacement, we can use the random dot sample. So again, this time, if you take a look at this, each of the results are different. So we will not choose it again and again. If you use the counter, you can see all the results only happen once. And now we go to another. If you remember, we already used this shuffle. So if you first print these two, it is the same as before, but after you use the shuffle, you can see the ordering is different. And we can also create a random number from uniform distribution. So you may have a floating values because this is not a integer. It just go from 0 to 100, and each will happen with same probability. And this is 92.21, and this is the random number from the uniform distribution. And the last one is the Gaussian distribution or the normal distribution. If you already familiar with statistics, you will already know that the mean is equal to 0, and the sigma is equal to 1 for the normal distribution. So this is the random number from the Gaussian or the normal distributions.